In your assignment today, you're going to need your calculator. We will be looking at some quadratic story problems. And I think most of what's there, you can find the answer using your graph. But you'll need to change your window and do a little bit of thinking. So turn to page 250. And we'll just start answering some of these, and then I'll cut you loose. Number 67. The annual profit for a company that manufactures cell phone accessories can be modeled by that function, where X is the number of units sold and P is the total profit in dollars. Now, before we answer this, let's talk about profit. What does profit mean? It's the difference between how much you spent and how much you earned. What do we call the money you earned? Revenue. Revenue. So revenue is the total amount of money that comes in, and then you have to subtract off your expenses, and the leftover is either your profit, or if you're not running a very good business, it would be your loss. So profit is the total amount you make after you subtract off all of your expenses. So we're going to be looking at the profit curve, and the function is negative 0.0001 x squared plus 70x plus 12,500. Can you tell me anything about this function before we graph it? It's upside down. Well, not necessarily. So we know that the graph is going to be upside down. It's going to look something like this. What else do we know? So we start at $12,500 because that's the y-intercept. So right here is $12,500. So apparently, if they don't sell any, if you don't sell any accessories, then they made money, right? Which doesn't make a lot of sense to me, but whatever. So we need to graph this. Plug it into your y equals. I'm going to make this big. So negative 0.0001 x squared. And it's plus 70x, and then plus 12,500. Now, if I graph this in the standard window, I'm not going to see anything. So what I recommend you do is pick your x values. What makes sense as an x minimum? 0. Right now, my x minimum is set at negative 10. Why is that a bad idea? You can't put the accessories back in the box and ship them back to China and get your money back, right? You can't undo your accessories. So we definitely want to start at 0. And then we're sort of just guessing. How many do you think the company's going to sell? I'll throw a number out there, 100. I don't know what the answer is. So my x maximum, I'm going to set it at 100. And if I set my x max at 100, what should I put as my scale? 5 or 10. Any one of those will work. And now, oh, sorry, thank you. So 100 and then 5. What do I know about my y values? Hopefully, we don't go lower than 0, but how high are we going to go? Well, hopefully higher than 12,500, right? But I don't have to make those decisions if I don't want to. If you have chosen your X window, you can ask the calculator to create the Y window, and it will create the Y window that captures as much of the graph as possible. To do that, you push zoom, and then I think it's 0 for zoom fit. Zoom fit will take your X window and create its own Y window. Well, it is. We just can't see very much of it. What do I need to do? We could zoom out, but that, well, let me try it. Watch this. So if I push zoom, and then I do zoom out, now I'm seeing some negative X's, and that didn't really help me much. Right, it doesn't look like a parabola. How come? What do I need to do to see more of this graph? My X's were way too small. If a parabola looks like a straight line, you are way too far zoomed in. So instead of 100, let's do 1,000. So 1,000. What should I count by? Probably not tens. 50s or maybe 100. 50 would be good. And then I'm going to push zoom 0 again. It's starting to curve. You didn't push zoom fit. So I need way more X's. Apparently this company is going to sell more than 1,000 accessories. So window, how about 10,000? 500 here. Zoom 0. Oh my goodness. Okay. Well, but we have to capture the vertex on our x-axis, right? 1 million's not enough? Okay, let's do 10 million. So 10 million. And then we better do 500,000. 10 million has 7. All right, zoom, fit. What does that tell me? We're too big now. So our graphs were looking something like this, right? And then I went so far out that all I see is that. So out here, I'm at 10 million. I need to come back in. Let's try maybe 5 million or 3 million. I'm going to put 3 million. You can try 5, see what happens. So 3. And then I'm going to take off a 0 here. Zoom 0. So 3 million still too big. What did you do? Oh, so 1 million actually was a good one? Sorry, I thought 1 million was too big. So 1, 0, 0, 0, 0, 0, 0, and I'll leave my marks at 50,000. Zoom 0. Okay, that's a pretty good graph. So it takes a little bit of calibrating to figure out which X values you want. Yours isn't showing up? Okay, let me see. Okay, if it ever freezes, just push on. So window from 0 to 1 million. Let's change that to 50,000. Zoom 0. There you go. Okay, now we have a good picture of the graph. Okay. Question A, what sales level maximizes the company's annual profit? What are we looking for? What about the vertex? So when I find the vertex, what will my answer be? The say it, Brens. No, I don't think so. The x value. What does x mean in this equation? Nope. X is a number of units sold. So we want to know how many cell phone accessories does the company need to sell in order to maximize their profit. So we need to find the vertex. If I push second trace, what do I do to find the vertex? In this case, it's maximum. Now, each one of my lines is 50,000. So if I look 5, 10, 15, 20, 25, 30, 35, it looks like about 350,000. Okay? Or you can just use your arrows for left bound, right? My calculator is just way too slow. So for a left bound, I'm going to choose 200,000. Just type in 200,000. You need to draw a lane that captures the vertex. So you can either, your calculators are a lot faster than mine, so you can just use your arrows and hit enter. But I need to come over here to like 400,000, and this calculator is just super slow. See that? Yeah, we are. And then once I'm over there, I can hit enter. Or if you know where you are, if you know your X scale, you can just type the numbers in. So I'm going to hit enter over there. Do those two lines capture the vertex? Yes, now the calculator wants a guess. So I think it's about 350,000. Yeah, you do have to be a little bit careful of pushing enter on your bound because it might be off. The calculator sometimes gets a little upset. So I have $350,000.06. What about that 6 cents? No, that is a mistake. The calculator made a mistake. Um, yeah. If you have like 2999999, that would be 300,000. So sometimes when you do left bound, right bound guess, depending on how far apart your bounds are and where you put your guess, your calculator will make a mistake or two in there. And sometimes you'll get something like this. You'll get like x equals 54.6 and y equals 3e to the negative 12. What does 3e to the negative 12 mean? Move the decimal left 12 places so it's 0.00000000003, which is 0. No, I don't care if you draw it. So, letter A asks, how many units do they need to sell? 350,000. Letter B said, find the maximum annual profit. If they sell 350,000, how much money are they going to make? So $12.3 million. Yeah, 12.3 million is fine with me. Okay, next problem. So 69. An adult male's weight in kilograms can be modeled by that function, where t measures months, where t equals 1 is 2010, t equals 2 is January 2010, and 2 would be February 2010, and W is the male's height. Let's type that formula in here. So negative 2/3 x squared plus 13/5 x and plus 433 over 5. Okay, now we need to choose a window. In this case, what does t stand for, or in our calculator, x? So t is months, and W is male weight. How many months do you think we're going to need? So 12 months would capture how much time? A year. Do you think a year is going to be enough? See how t is, do you see what that says right there? It gave us the domain. So apparently this function only works from January until 18 months later. Right next to the equation. So 1, 2, 18. And I'm going to count by ones. And now I just push zoom fit. Not sure. An adult male's weight in kilograms. Well, type it in right.
Well, doesn't that mean he weighs like negative
That's
negative
wrong equation. All right. Yeah, that does look kind of weird, huh? So So an adult male's weight in kilograms can be modeled by that function. An adult male. So this is just one person. Did I get the function right? Negative 2/3 plus 13/5 x. Yeah, huh. Cynthia. Okay, if I look at my graph, part of this graph doesn't make any sense at all. What part doesn't make any sense? The negative. So I'm going to count back. If this is 18, 17, 16, 15, 14, I'm going to change my window, and I'm going to stop at 14. And I'm going to zoom fit again. That way, this really is a terrible question. Okay? Right. But do you notice that there is a portion of the graph where they're gaining weight? And then from right about 2. Why is this line on the left side dotted? What does that tell me? Right. It means I don't have the y-axis. So even though this is a really dumb question, here is my Cartesian plane, and I'm looking at this much. Right? I can't see the y-axis. And anytime you can't see the y-axis, then it's going to be dotted. And one of the bad things about Zoom Fit is you have to choose the y scale. So I look down here, my y scale is at 1, but it goes from -7 to 89, so I probably want to go by maybe 4s, and then you'll see it a little bit better. So when you do Zoom Fit, you have to go back in and change your y scale, or you just know that I don't see the y-axis in this case. But it looks like from 1 to 2, this guy's actually gaining weight. So it looks like the graph goes up a bit and then down. And from 1 to 2, then the weight is going up. And then from 2 to like 13 and a half, it's going down, but it doesn't make any sense. You're not gonna weigh 0. You're not even gonna weigh close to 0. So let's find the vertex anyway, just to see if it's at 2. These are kilograms. Yeah, kilograms. So second calc, I want to find the maximum. Left bound, I'm going to do 1. Right bound, I'm going to do 3. And my guess, I'm going to do 2. So 1.9499999. Can I assume that's a mistake? It probably is. Let's do trace 2, 89. What did the y value say before? 0.135. So actually, it is 1.99. Okay, that was a really dumb question. So, during which month was the male losing weight? So all of January, they were gaining weight, and then, well, right before February started, he started losing weight. Yeah. Yep. So February on, he was losing weight. And apparently, not only did he turn into nothing, but he became negative weight. He started lightening anybody who was around him. If you stood next to him, you weighed less. Yeah, that doesn't make a lot of sense. Okay, 71. We have that function, the path of a particular punt, -8 over 125 times, this is 71, x plus 5 squared plus 40. So h of x is the height, and x is the horizontal distance. X equals 0 is the 50-yard line. And then x equals -20 corresponds to the punter's own 30-yard line. So let me show you what that means. So we have this, and this right here, 0, is the 50-yard line. Okay, so what should I choose for my window? 20 is probably not going to be enough. -50 to 50. So -50 would correspond to the goal line on the punter side, and then 50 would represent the goal line on the returner side. So let's do -50. That's the punter's goal line. And 50 would be the receiver's goal line. And counting by 5s, that would work. Well, you want somewhere between 10 or 20. Yeah. You always want your scale to have a 10 or 20 units. So if we do 5 yards, I'd have 20 units. If I did 10 yards, I'd have 10 units. Either one is fine. It's just your label will just be a little bit different. Okay, zoom 0. Now some of this graph doesn't make any sense. What doesn't make any sense? The y being negative. So I'm going to go into my window, and I'm going to change the y minimum to 0. And the scale from 0 to 40, and I count by 4s, that would be 10 marks. 2 would be 20 marks. So either way, I don't really care. I'm going to change this. I'm going to round it up to 40. Okay, so I did 4. 2 would work. 4 would work. So where was the ball kicked? So if we count 0, 5, 10, 15, 20, there is no 60-yard line. No, that's just an example, right? So it says x equals negative 20 corresponds to the punter's 30-yard line. So that's just saying which side the punter's on. That was just telling you that negative 20 would be the punter's 30 and positive 20 would be the receiver's 30. So if we count 5, 10, 15, 20, 25, or sorry, 0, 5, 10, 15, 30, the punt started at the 30. 20. I can't count. Let's try that again. 0, 5, 10, 15, 20. I did it. Well, no, it's 20. Well, so this is the goal line. 5, 10, 15, 20. The 20-yard line is where the punt started. And then the punt lands at the 0, 5, 10, 15, 20, 25, 30. Did I count that one right? So 0, 5, 10, 15, 20, 25, 30, right here. The punt lands right there. Okay. So A wants to know, what is the maximum height? I know it's 40. How come? No, plus 40 is the y-intercept, right? But the y-intercept is not actually the maximum. So we need to find the vertex. So second calc maximum. And I'm going to go from negative 20 to, oh, let's do 0 or 10. And I'm going to guess negative 5. And it is 40. Oh, it's in vertex form, huh? Okay, you're right. Sorry, Riata's smarter than me. Yeah, these are yards. So the punt went 40 yards in the air. And then B, find the horizontal distance the ball covers. It's 50 yards because you have 30 on one side and 20 on the other. So that would be a 50-yard punt. But that's not how we measure punts. We actually measure punts from the line of scrimmage. So, but they didn't ask that. They just wanted to know how far did the ball actually travel. Okay, 73, and then I'm going to let you guys go. Ranching. This is right up your alley. A rancher has 10,000 linear feet of fencing and wants to enclose a rectangular field and then divide it into 2 equal pastures with an internal fence parallel to one of the rectangular sides. What is the maximum area of the pasture round to the nearest square foot? Okay, this one is a little bit tricky. We have a rectangle, and we're going to cut the rectangle in half. Okay. So we need to choose a variable. What should we call x? Because it doesn't really matter. One of these lengths needs to be x. Okay. So you want to call this x. Okay. Which means this is also x. Okay. Now, how long are the other sides? We could say y, but then we have 2 variables, and they're almost. What do I know about the remaining 3 sides? They're all the same length. Okay. Right. I know there's 10,000 feet of fencing. So we have called the long sides X. So we have used 2X fencing, right? We started with 10,000. And how much have I used so far? I have taken away 2X. And then the remaining fence is going to be divided among 3 equal lengths. Because, so I have 10,000 feet of fencing. And I use this much fencing, X. I don't know how much that is, it's X. So I have 1,000 minus X left. Now I build that fence. Now I have 1,000 minus 2X left. And that remaining fencing is going to be divided among 3 equal lengths. Right. All right, now let's choose X as the other variable, and let's see if that makes sense to you. Let's call this X. How much fence do I use when I create that? I use X. And then if I build these, I have now used 3X, so what's left? 10,000 minus 3X, and what am I going to do with that fence? I'm going to divide it by 2. So I have 2 possibilities. Well, I just wanted to see if you understood. That's this piece. Yeah. Yeah, he just wants to divide it in half. No, that is the internal fence. Okay, so we have 2 different equations. They'll both work. It just depends on what X is. So let's start with this. Okay, this number will help me figure out how big X is. But what's the whole point of this? What do I want about the area? I want the maximum area. So what does this number tell me? That's how big the short sides are, right? So we called the big side X. We subtracted off 2 big sides, and we divided it by 3. So this is the length of the small side. Right. So what is the area of this rectangle? It's just length times width. So length times width. Well, that's how we built it, right? We took 10,000 feet of fencing. We subtracted the top, we subtracted the bottom, and then we divide it by 3. So each one of these is this big. Now that's kind of a messy number, but we can now find the area. It's going to be X times 10,000 minus 2X over 3. Do I even need to multiply that in? Just type it in your calculator as is. Yes. Oh, okay. So we could just find the answer and divide it by 2? Okay. So you either divide this by 2 or you divide your answer by 2. So in my y equals X times 10,000, maybe, 10,000 minus 2X divided by 3. Okay. What should I choose for my X values? What do I want as the lower bound? Definitely 0. We can't have negative fence. And then my maximum can't be higher than 10,000. In fact, you probably don't want to be close to 10,000 because you have 5 fence lengths. So maybe 2,000 or 3,000. So, Jimmy, where are you stuck? So, we want to know how big should I make these fences to capture the most land possible. So, this plus this is 10,000. And X is just the length of the top. So I don't need to go from 0 to 10,000 because that would be a fence that's just a straight line. So 5,000 is probably still too big because that would be two straight lines, right? It would look like this. So I'm guessing 2 or 3,000. And we might have to fix it once I plug it in. So I'm going to say 3,000. And I'm going to, oops, 3,000. And I'm going to count by 300. And then zoom fit. Did I capture the maximum? Yeah, I did. So my maximum is over here at 3. So for left bound, maybe I'll do 1,500. I did 0 to 3,000. Oops. 0 to 3,000. Did you do zoom fit? Let's make sure your equation is right. Oh, your divide is on the inside. You need to divide the whole thing. Oh, you'll need to zoom fit again. Okay. Second calc, maximum, I'm going to guess maybe 2,000 for my left bound. Oops, that's not going to work. So maximum 2,000 as a left bound. And then maybe 3,000 as my right bound. And my guess, I'll say 2,500. So can we say that that is exactly 2,500? Yes. And then the Y value would be exactly 4. So 4,166,666. Okay. So what does that tell me about this picture? What did I find out about this? We got X equals 2,500. What does that tell me about the picture? The long side is 2,500. So this would be 2,500. And so if this is 2,500 and this is 2,500, how much is left? 5,000. So each one of these is a third of 5,000. The short side is going to be a third of 5,000, which is what? It's 500 over 3. Or sorry, 5,000 over 3. So we have 10,000 feet of fencing. We found out that X is 2,500. So the top is 2,500 and the bottom is 2,500. That's 5,000 feet. So what is 5,000 over 3? 666.7. Okay, and it wants to know what is the area of 1 times this by half of that. Because we just want the area of 1 pasture. You're going to get 20.5. 205 something something something. I think you had too many zeros. Oh, really? Oh, so how did I know it was going to be 20.5 or 205? Because it's going to be half of that right there. Well, 208. That's close. So look at my Y value. When X is 2,500, my Y value is 4,166,000. That is the area of the entire pasture. So we could have just cut that in half. Well, I wanted to show you both ways. Now, you don't need to do this, but I'm going to type in my other equation. So this equation right here will tell me the length of the short side, right? Or no, sorry, the length of the long side. So if this is x, yeah. So if this is x, then I have 3 x's. Subtract that from 10,000 and divide by 2, and that will tell me this. So that value is this length. If I multiply those together, so x times 10,000 minus 3x divided by 2. And I'm going to do the same window and just graph it. Now, when I find my maximum, what will the x value be? It's going to be smaller, but I do know exactly what it's going to be. It should be this number right here. So, second calc, maximum from 1,000 to 2,000. And I'm going to guess 1666. And it is 1666. Okay. So you have almost half an hour to do 70. So the answer is half of this. Half of 4 million, so 2.08 million. Yeah. So you need to do all the way to 85. So you have 1, 2, 3, 4, 5 questions to answer. Okay? Good luck.